What's up guys, welcome back, and today we'll be solving valid parenthesis problem. This problem falls under easy category and it's actually very easy to solve. So a string will be given to you and you just have to find whether the parentheses are in order or not. So the rules are open brackets must be closed by the same type of brackets. Open brackets must be closed in correct order. So the examples are one, then this, and it's really easy, right? This is the false one because this is the square bracket. So the way they are closing is not correct in this, so this is false. And let's see how to solve this. So one thing to note here is they already said that empty string is also considered valid. So let's handle that first. So if s dot length equals to 0, then return true because that's a valid string. If not, then we need to have one index which we'll traverse, and we'll use stack here, which will actually hold our character. Let's name it as stack only. Okay. So what the logic behind this problem is, we'll traverse through all the characters of this particular string, and while traversing we'll actually check whether it is opening bracket or closing bracket and the following rules. So let's see how to do that. My condition here will be while index is less than s dot length, because we'll be traversing through all the characters, so that's correct. And let's have char here, so s dot caret end. Now let's check this character. So if my ch is equal to this here, or ch is equal to square opening bracket, or ch is equal to curly bracket. So in this case, what we need to do is just to push it in our stack. So stack dot push ch. Now if this is not true, okay, okay, else if, let's first check if my stack dot is empty. So if my stack is empty and I don't have opening bracket here, if this is true, then return false, because what I have is closing bracket and my stack is empty, so I don't have any opening bracket in front of it. So my output of this is false because the string is not correct. Again, else if, okay, if my ch is equal to yeah, okay, this, and my stack dot peak for this variable is equal to opening bracket, or my ch is equal to bracket here, and stack dot peak opening bracket, or okay, my ch is equal to this bracket here, and stack dot peak So if any of these conditions are true, so what we just need to pop out, push pop, yeah, that's correct, pop out our stack, and at last we just have to increase this pointer here. That's it. And let's return stack dot is empty. So why we are returning is empty? Because there can be a string where we just have opening brackets without any closing brackets. So in that case, we'll be pushing all the opening brackets, but we won't be popping anything out. So our stack won't be empty. So in that case, again, we have to return false. So this particular statement here will consider all the cases. Let's see if it works. Perfect. Oops, there's some problem. And what's that? So we are actually pushing it first and then we are checking for the closing bracket. So if my ch is this and stack.peak is equal to this, oh, okay, we actually missed one of the else. So in this case also return false. So if any of the above conditions are does not meet, so we have to return false. Let's try again. Perfect, this time it worked. So what we did in our solution is we traversed through all the characters of the string, and we have some of the cases here. So if the character is any of the opening bracket, we'll push it in our stack. If this is not true, then we are sure that the character is one of the closing brackets. So we'll check first our stack should be not empty, and then we'll try the combinations of these brackets accordingly, and we'll pop the element, the last in first out, right? The stack is something that this follows, and then we'll just increase the index here. Talking about the time complexity, so the time complexity of the solution will be O of n, that is linear, because we are just traversing through all the characters of the string. Also the space complexity here will be linear, I would say, because what if all the opening brackets are together at the front and then comes all the closing brackets? So in that case, we'll have all those brackets stored in our stack. So it will be somewhere around n by 2, but that's again linear, right? So that's it. Hope you like the video, and if you do, do not forget to like and subscribe. See you soon.